All right. So yes, Dan Stewart with Automation Alley. I am the Director of Sales for the organization. I've had a background in engineering through brief employments at Ford Motor Company, General Motors, and also the well-known engineering services provider here locally known as Roush Industries. So I'm looking forward to seeing the presentations this morning. It did surprise me. I thought that the 8 o'clock time was evening, and I discovered that it was morning. So this is actually better. I rather prefer this. So looking forward to hearing what the students have to offer and learning something along the way as well.
Thank you for joining, Dan. Yes, this is an early class, so it's a struggle throughout the semester for all of us.
I see some people yawning.
We have our coffee with us.
Yeah. Well, if you'll indulge me, I've got a few moments here. I can make a pot of coffee. I'm going to run off. I'll join you.
Not a problem. We're going to wait till 8:05 at least for others to join. I see Paul here also. Paul, you want to introduce yourself?
Good morning, everyone. Yes, Paul Santee from Fanuc America in Rochester Hills, just around the corner. Thank you for the invite, Khalid. Appreciate being here. I've been at Fanuc almost 28 years, all on the system integration and system engineering side. So I'm interested to see what your compatriots here have come up with, some ideas, and see how these apply to the industrial space. So yes, 8 o'clock is early, but I did have a 6 o'clock call with my ISO global robot safety colleagues. So I've been up for a little bit, but still working on some coffee and tea.
Thank you for joining, Paul. I'm in the same boat. I just switched from another Europe meeting to this class session. So yeah, so this time works for me too. So students who are joining, please make sure you have your webcams on also. Is there any other guests? Clemens, I see you joining. Do you want to introduce yourself?
Sure. Hi, everybody. Good morning from the OU building, actually. So I'm Clemens Conrad, the practice lead movement at Vectorform NTT data company. I'm focusing on digitizing the vehicle interior, as well as go-to market strategies with our partners and clients, including Stellantis. So, and we are actually exploring quite a few of those AI topics that you're presenting today. So I'm really excited to witness what you got going. So really excited to be here today.
Excellent. Thank you for joining, Clemens. Great to have you here. All right, we're going to wait a few more minutes before everyone joins, and we'll start our presentations at that point. And again, a reminder for all students to turn on your webcams. Also want to make sure, Adam, you're ready with your presentation.
I've got it up. Do you want me to test again?
No, we'll test it during the presentation.
All right, sounds good.
Yeah, we're almost ready. Yeah. All right, so let's formally start the presentation session. I want to thank you all the guests who are joining, and hopefully others will join too. And this is always the most exciting part of our class. At the end, our final project presentations. Just to give everybody who's joining now from outside just a overview of this. This is an open project. I let the students decide what application they want to work at, and use the knowledge they have learned during the class. And believe me, this is the first time they look at computer vision, and the first time they look at artificial machine learning and other areas, and they're putting it all together within 4 weeks to come up with a working application. So this is always exciting what the ideas they come up with, and and the very creative work which they do, and working working applications. That's always a big thing. So we will have 5 groups today presenting their projects, and for each of the groups, you will have about 20-minute time slot, out of which 15 minutes are for showing your, first of all, introduce your group, what is the application you're working on, and then show the demonstration video so we can all see what the application you made, and then you present. All team members should participate in the presentation, and we will reserve 5 minutes for question and answers from your fellow students and from our guests, and of course your professor also. I'll keep track of the time and remind you when you're getting near the end of your time slot. So with that, I am going to start. I'm going to unshare my screen. And Adam, you are the first one. You are doing vehicle preset automation via facial recognition.
Yeah.
Take it away.
Alrighty, let me make sure everybody can see my screen.
We can see your screen.
Perfect. So hi everyone, I'm Adam Kidwell. My partner is Nishchay Kulkarni, and our project is facial detection for vehicle presets. So we realized that in a household, a car may be shared between multiple drivers. Sorry, my Zoom crashed again. You guys hear me?
We can hear you.
Sorry. So yeah, it's likely that these different drivers need to readjust their seat positions to be able to drive safely and comfortably each time they get in the car. And this can be quite the nuisance. So technology currently exists to load seat presets for each driver by saving settings to unique key fobs. But this isn't always convenient to keep track of your individual key fob, and it's certainly possible to have more drivers than keys. So realizing this problem, we wanted to develop a smarter and more convenient way to identify which driver is entering the car. We decided to utilize a convolutional neural network to learn each driver's face, allowing us to load in the preferred seat settings. Sorry, my Zoom crashed again. I'm having a lot of technical difficulties. So in our project, we train a CNN to distinguish between 2 drivers' faces. Below, we can see the general structure of a CNN with an input layer, hidden layers, pooling layers, and a final prediction layer. So first, we take 3 images of each face. Utilizing image augmentation, we create a data set from these 3 images that we use to train our network. Our trained network then recognizes the face of each driver and loads predefined seat settings that are assigned to them. So like we said, to start, we take the 3 pictures of each user. So we display a frame with the user's camera feed so they can see the image they're submitting. An object detection algorithm is used to detect any faces in the frame and draw a red box around them. Once the user visually confirms that the red box is around their face, the picture is taken. To remove background noise, only the portion of the image inside that red box is saved. This is repeated 3 times for each user with a slightly different angle to give us some variety. With these images, we use image augmentation to make 50 more unique pictures from each of those 3 starting images. That gives us 150 images that we can use to train our CNN. So now that we have the images, we have to prepare them for the CNN. So we resize them all to 150 by 150 pixels. We convert all the images to grayscale. We assign labels to each of the images for training. And these images can be saved. So you can add additional images to the data set, maybe on another day or in a different outfit, to make the predictions more robust when you train the CNN. So once both sets of images have been prepared, we shuffle them together to ensure the network trains efficiently and doesn't simply learn to always guess one user on one epoch and then the next user on the next epoch. And now I'm going to pass it off to Nishchay to talk about the structure of our CNN and a little bit about the GUI that we made.
Let me interrupt you guys. Do you want to show the demo video? We didn't see that yet.
Yeah, absolutely. Pull that out.
Make sure to share the screen also, because we're not seeing anything.
You're not seeing it?
No.
Okay. Did my screen stop sharing? Oh,
Here we go.
okay. Sorry about that.
No
Let me know
problem.
if it disappears again.
We're not hearing the audio.
Okay, let's. Okay, can you hear now?
Yes, we can.
Okay, third time lucky.
Not a problem. Let's do it.
Hello, everyone. My name is Nishchay. I'm Adam. We're here to talk about our final.
Okay, we're having Zoom problem. Let me see if I can pull up your video here and show it from my screen.
Yeah, it really doesn't like me trying to show this.
Okay.
I'll stop. Am I sharing?
Then Nishay, do you have the video you can play from your screen?
No, I don't have the video, but if Adam sends it, I can play it.
Okay. Let's see if we can dig up the video.
Yeah.
Sorry, everyone, for this slight technical difficulties. It's part of the training procedure in the class. I'm going to see if I can dig up your video and play it from my screen.
I'll keep working on sending it. We'll see who's first.
Okay, I think I located your video. Give me 1 second. I'll play it for
Sounded
you.
like it.
All right. Can you see the video screen?
Yeah.
All right, here we go.
Hello, everyone. My name is Nishchay. I'm Adam. We're here to talk about our final project for machine vision. So for our final project, we decided to make an application using a convolutional neural network that can recognize a face. This application is meant to be used inside of a car and can be used to recognize the driver's face and load their preferred seat settings for a more comfortable ride. The way we approach this project is by taking 3 pictures of the driver, one from the front, one from the right, and one from the left. This allows us to create our own data sets and train our CNN model. By training the CNN model, we are able to recognize the driver and load the car seat settings and different types of settings throughout the car for a comfortable drive home.
Yeah, in the interest of demonstrating this to you, we put together a little skit that we're going to play for you now.
Enjoy. You ever get in the car and seat settings all bad and you're just sitting like this, feel all uncomfortable? Guess what? We have a solution for you. Facial recognition coming to the rest. We're going to come here, skin detection, and we're going to train a model that's going to recognize me and my car setting that is going to implement right onto my phone. First, look right into the camera, hit OK, look straight in. Picture number 1. Give the camera a little side profile so it recognizes you even better. Picture number 2, and the left side profile. Picture number 3. Now that the pictures are taken, the model's trained and it's ready to give me my car seat settings. As you can see in the top left corner, it says Nishchay. All you have to do is hit yes to load your car seat settings. Boom. You can sit like a king when your car makes sense. But Nishchay, what if I prefer the first setting? Well, guess what? You don't need to worry about that because it can recognize you too. Just come right here, click begin. And boom, you can see Adam right there. Boom. Now that your seat settings are loaded in, you can get back to sitting like this. Yay. Hopefully it was an enjoyable skit, and hopefully we're also able to demonstrate the usefulness of our product. Thank you very much. Have a great day.
All right, you're back on.
Thank you for helping me out with that.
No
So,
problem.
sharing again here. Yeah, can you guys see?
Yes.
Perfect. So just a little reminder of where we were at. We were just talking about how we take the pictures, isolate the face, and then augment the images to get a data set. We can see examples of the augmented data set in the bottom right. You saw that it trains the convolutional neural network. So let me pass it up to Nishchay now, who will tell us about the structure of the network and talk a little bit about the GUI we made.
Thank you very much, Adam. So good morning, everyone. I'm Nishchay, and I'll be talking about our CNN and preparing data sets and all of that stuff. So as we saw in the video, we prepared our own data sets. We took the 3 pictures and we generated 150 images from it, 50 from each angle with all the changes made to it. So this allowed us to create our own data set, which was very convenient. And we were able to create the CNN where we have 150 by 150 by 1 input layer feeds through 4 hidden and polling layers before reaching the final prediction. We also use a 2x2 and a 3x3 window size in the polling layers, a rectified linear activation, and end with sigma activation in our final layer. When we compile the model, we use loss of mean squared error and then applied the name Adam optimizer. So as you can see in the image on the right side here, you can see that's like the scaled down version of what our CNN model looks like. So it takes in all the images and then it goes through all the convolution layers. At the bottom, you can see all the weights that we have and the biases that we have set for them. And the bottom box where it says weights kernel 73984 times 1, all bias 1, all that, those are for the model that we trained and created. So it just kind of gives you an idea of how we worked on and created our own CNN. Here we have the GUI portion. So we used 2 major Python libraries called tkinter and ctypes. So tkinter is a pretty popular Python library where people create windows, text boxes, buttons, things like that. And we referenced tkinter and their information available to create the main GUI stuff that we wanted for our project. So we have the GUI main screen, which was created on tkinter, and then in figure 8, the saved seat settings. We created a slider bar where we were able to control the seat settings. And once the face was detected, it would go to save seat settings, and then you can see how you want to adjust your seat. That's more of like a visual representation of how we wanted to control the seat, because we found that to be a pretty easy and convenient way to demonstrate one of the outputs of our product. And then ctypes allow for pop-up windows. So once a task was ready to be moved on to the next stage, we created a pop-up prompt. And then from there, we just asked, as we can see in figure 7, it says, if it has recognized you correctly, would you like to see the seat settings and make changes to them? So once it's more like a validation where you validate whatever the software is working on. And if you believe it to be correct, then you can go ahead and proceed and move on to the next one. Predictions. So predictions can be viewed on the frame they were taken from. So as you can see, we have 2 images where the trained model that we have detects me and Adam. I know the green might be a little tough right now to see, but in the top left of me, it says Nishchay, and then on the top right of Adam, it says Adam. On average, whenever we trained throughout, we got about 65 to 70% validation accuracy, which we were pretty satisfied with. So most of the times when we ran our testings, when we ran our product multiple times, we were able to get appropriate detections and recognitions from our software. And then we did not have time to properly calculate a practical accuracy through systematic testing, but in the process of creating the program, we only ran into incorrect predictions a couple of times with just like a dozen predictions. But this was more, I would say, early on in the project or early on in the testing processes, but later on, I would say it kind of got better and we were pretty satisfied with that. Conclusion summary, well, as we can tell, CNNs are pretty incredibly powerful, even with limited data. With the 3 images that we took and putting them through augmentations, we were still able to get a pretty good accuracy, and we were able to recognize me and Adam, and it was able to distinguish both of us. So that was really impressive to look at. Possible improvements is lighting. So one of the issues I ran into is whenever I tested in different environments, so in my room, it would work fine. But when I did testing at my friend's house, he only had 1 light in his room, and there the software would crash because it was not able to put a bounding box on my face. And some of the values of the bounding box were necessary for us to make certain processes in the next steps of the program, and it got zeros in there, and which would lead to the software crashing. So lighting and having better lighting obviously helps these types of software a lot better. Additional input images. We also realized at one point when we didn't clear out our augmented images, we realized that our prediction patterns started going up and prediction percentages started going up, sorry. So if we have more data sets, obviously we're going to have a lot better image recognition and distinction between 2 types of people, which in our case was me and Adam. Network structure refinement. This is more in the CNN thing where we can refine how our CNN was laid out. We mainly referenced the more common one that TensorFlow had, and we went more with the general one and then just kind of fine-tuned it to whatever we thought worked for us. But I feel like if we would spend more time with that and make a more better detailed CNN for us, I think this application might be a lot more robust and a lot more smooth working. And that should be all. Thank you very much.
Thank you, group number 1. Great presentation and demo video.
Thank you.
Thank you.
All right, we have 5 minutes for questions. So I will open it up to the floor if there are any questions for this group. Anybody can ask. Okay, if not, then I will jump in. Well, how many images did you say you needed to train the app for each person?
Yeah.
So, okay, go ahead.
Okay, so we took 3 images. One was the front, like straight looking into the camera. Second one was from the right side, so your right side profile, and the other one was your left, so your left side profile. And we took those and then we augmented each image, and we converted 1 image into 50 images where it was like augmented as seen in the presentation. Okay, so just 3 images were sufficient to recognize the different people.
It's that's 3 per user, but yeah.
Yeah, that's excellent. Because, you know, in a real app, in a car, you're not going to be sitting for 2 hours taking images of all possible ways to do it. How hard was it to create this machine learning app? I know this is the first time you guys are looking at machine learning and all. Share that.
It was like a good week and a half of just trying to figure out how to tackle the problem and get any facial detection at all. So it was a lot of fine tuning the CNN itself and figuring out how do we approach the problem of detecting a face? Because originally we wanted to be able to use it with 1 user at a time. So like train the CNN to recognize my face and be able to say, you know, the Adam is in the frame or Adam is not in the frame. And that turned out to be a very difficult problem for us to tackle. We spent about a week on that, got discouraged. We tried to use brute force matching instead of a CNN at one point. That didn't work at all. And then eventually we realized that we could kind of like a cats versus dogs example. We could do Adam versus Nishchay or user 1 versus user 2. And when we figured that out, it kind of all fell into place, and the model we had already been tuning just worked perfectly.
Right. So yeah, that's a good approach because again, if you're using a classifier for your machine learning at the end, it's going to select with one of the given choices. And whoever user enter their name is one of those choices. So what is the best possible match is what it's going to go with. So hopefully you don't match with somebody who's very different size on the seat and they crush you in the car seat to adjust to that. Any questions from anyone else there? We have still a couple of minutes.
Yep.
Go ahead, Dan.
Yeah, so I'm curious. I did a little bit of research on this because I know absolutely nothing about it. So I looked up a little bit last night and tried to learn a little bit on this. Part of the definition of the problem was the proximity of the camera to the image and the camera itself. Was there only one choice? Were there other options available to select different cameras, different lenses, or was this kind of a static approach?
Yeah, so in our project, we just used the webcams on our laptop because it was convenient because we kept coming to school, going back home, things like that. So carrying a webcam or external camera was kind of annoying, I would say. But I would say, depending on if you have a better camera, I for sure would say that it improves your recognition, because I think if you make changes in your lenses, you can also get like better light exposure, and having better light exposure obviously will help better facial recognition. And at least I'm not sure about the recognition, but for sure it helps in the detection portion, because lighting is one of the key aspects just to at least even recognize and detect your face. So that would for sure improvise how the way the software performs. But for our case, we just use the webcam on our laptops.
Yeah, and we did have a few measures implemented to try to mitigate the effect of using just this one camera, like having the bounding box that recognizes the face and then only taking the face can kind of eliminate the problem of how far you are from the camera. And then since we resize all the images down to 150 by 150, the resolution is also less of a problem. So, and then of course we want you looking in different angles relative to the camera. So just having the static camera position makes that more convenient.
Excellent. How would you handle the lighting problem in a car? Because I'm assuming the camera is in the car. As you enter, it recognizes you and adjusts everything.
Yeah, so that's a great question. I would think that wherever you mount the camera, you'd also want to have a light and pretty much only activate that light when a user comes in and says train my face. And then like you have a static light, you kind of expect how it's going to work. And then maybe if they have the facial detection enabled as they're entering the car, that light is on to
Right.
recognize their face.
So like a spotlight on you, it's trying to recognize you. But
Yeah.
so this is exactly the same problem if you use computer vision, machine vision in industry. Is lighting is always one of the key things. And sometimes when the environment does not provide you enough light, you need to control it by providing the light. So I think you guys learned that firsthand by doing the application. Kudos to you. You did a great job and great presentation and great demo.
Thank you very much.
Thank you, everyone.
Okay, and we are ready to move on to our next group. Group number 2 is doing a Lego block finder. So take it away, guys.
Okay, we'll start with our video. So we did Lego detection and we are Sean and Emir. So.
Hey Sean, what's wrong?
I have all these Legos here and I can't find my people that I have mixed in with them.
Oh man, what should we do? Maybe you should try using machine vision, using ORB detection like we learned in Mirza's class.
Would that work?
Of course it would work.
Huh, I guess I didn't think about that. Maybe we should try it.
Yeah, of course. So, like, it would detect all the edges from your pieces and then it would make the detection super easy.
Huh.
Yeah. I think we should try to locate your gingerbread woman first.
Oh, perfect. All right, let's try it.
All right.
Okay, let's see. I want to find the gingerbread man first, so I'll click 1 and hit enter. Okay, so this is the one I'm looking for, and let's see if we can match it with anything over here. It's not this guy. A lot of different matches over here. And here we go. This has a lot of matches, so I'm going to assume this is it. Well, that worked, but I still have 2 more people that I have to find in my Legos. How am I supposed to get those? Do I have to change the whole code?
No. So actually, the way the code is set up, you use specific numbers for each of the 3 people, like the Legos, and we use 1, 2, or 3, and then each numbers is a specific one.
All right. Oh, now I see it. So if I want to see Mrs. Claus, then I'll just select number 2 here, and I'll hit enter on that. All right, that's what she looks like for reference, and let's see if we can find her over here. Not many matches, really no matches over here. A little bit better. Oh, and there we go. Pretty much everything matches up with her, so that's got to be my next one. All right, and my third option is the boy, so I'll hit 3 and hit enter. All right, and here's our last image we're looking for, and let's see if we can find that. There's not much over here. Not much over here, but when we go to the middle, it matches a lot with this one, so that's got to be our guy. Wow, that worked. I found all my Lego people. I can't believe we learned all that in machine visions, and it's that easy to locate things like that now.
Yeah, thank you, Professor Mirza. This class was really helpful.
So an introduction to our issue, and this actually, funny enough, came up with working on this project because I had to buy a new set of Legos, and I, in the end, tried to put it together. And one of the issues we have is when we're searching for these Legos, you end up, looking for a piece, and you look right over it 15 times and never end up finding it. So we wanted to find a way to use machine vision to locate that piece with your camera, so it's easier to find. And our strategy chosen was ORB detection to find the key points and point them out in the image. We were going to try and find the object with the most matches, and we were going to put a bounding box around it, but I think my theories with the video, the matches didn't all match up enough to put the bounding box, so it ended up just shooting across the screen and not actually zoning in on it. But some of the other options we had were machine learning with cascade classifiers, and that we didn't end up working out, which we'll go over in a second. And the edge detection, which we used, and it worked fine. And with that, we were going to basically just detect the exact shape of it, and then just find everything by its shape. But with Legos, the issue was that the dimples on the Lego were then detected. And then blob detection was another option, but it couldn't quite be specific enough for each individual Lego. And now I'll pass it off to Emir to go over some of the actual issues with these other options that we came with.
Yeah, so some issues that we ran into, we couldn't really find pre-made cascade files online, and the ones that we tried to create ourselves weren't working. So we were running into issues there, and we weren't able to fully make a box go around the Lego to identify completely. And of course, the timing was a little bit of an issue because it took us about a week to get something that we could actually test and start and whatnot. And you can go to the next slide. And some what ifs. If we would have been able to create our own cascade file, or maybe even use a different option such as blob detection or edge detection, we maybe would have been able to find a more obvious detection of the Lego, or even be able to find the other Lego pieces and not just the people. And some conclusions. So the ORB detection, it worked well. It worked pretty well for our project, but I feel like something could have been better because what I noticed with the ORB detection, it didn't work well with rotation. And I don't know if it was something maybe wrong with our code, but every time there was a sudden movement in our camera, the system would just crash. So I'm not really sure if that was just our code or if it was just because of that type of detection. So maybe if we would have tried something else, we would have had something better.
Any questions for anybody?
Great job, group 2. Good presentation, good video. All right, we are open for questions from anyone here. Any Lego players here who want to ask any question? You guys get extra credit, students, if you ask questions. You're very quiet.
Can I ask myself a question?
Go ahead.
Me? I was kidding.
Oh, it's you.
Yeah.
You cannot ask yourself a question and
Dang
answer.
it.
So
Do
I have a
extra credit for that?
question.
Yeah, go
Yeah,
ahead.
Go ahead, Adam.
So when we did the facial detection, we tried to use brute force matching, and we struggled kind of with the robustness. Like you mentioned earlier on, you couldn't put a bounding box because there'd be like a few predictions that weren't accurate enough.
Yeah,
Were there any steps you guys tried to take to improve that accuracy?
absolutely. I've tried to, I mean, we tried different cameras that were with better quality. We tried to get more lighting and different angles. I tried to get more exact distance from the Lego piece that so it matched with the picture better and moving it around. And none of those seemed to work to get enough matches. And really, even when it did hit with all the matches, the bounding box for some reason still didn't zone in on it. So I don't know what caused that, but we couldn't
Yeah,
seem to
so-
get it to zone in.
One of the issues when you're using orb or key point matching is how many key points are you recognizing, and if that the object which you're trying to match is feature rich. I'm sure those Lego pieces were very, very similar. So would you think that machine learning would have been a better approach here to?
I do. What came up with machine learning, we actually worked on it for a while. It's part of the reason like our code ended up being simpler is because we spent probably a week or more on just trying to figure out machine learning. And one of the things we discovered is the online resources are mostly to do with facial recognition and body recognition, not with shape detection and things like that. So we couldn't find that because we started with finding anything with Legos, nothing came up, and we switched to shapes. And even then it was hard to find. And so then I tried to create my own using the like system and then using the external like cascade classifier system. And for some reason, no matter how I moved around the information and no matter what pictures I used, it was unable to detect like one Lego or detect a Lego or in a video, even though I used the same code with like facial recognition and it worked fine.
So yeah, I hear you. It's not a trivial problem if you're creating your own set of training set for your application. And I do realize you guys had a limited time. So at least you tried and you got you know what it takes to do something like this. And if given enough time, do you think you would have created a training set for those Lego pieces? And what's your thinking that it would have worked better than using the orb?
Yeah, I think absolutely. If we had more time, we would have been able to pull together the machine learning files necessary to detect Lego pieces in the picture. And I think another issue that came up with that is we would have then had to been able to still detect individual Lego pieces, not a Lego piece as on its own, or not any Lego piece, because that was the point of our project. So that would have been another thing to work out if we had more time.
Okay, so now I want you to think a little bit out of the box. Do you think you can make it a product? What would it do really?
What would it do? It could be something that in the end they could sell, like, let's say it's a code or something you scan with a Lego set. So then it knows what Lego set it is and it knows what step you're on. And you can then shine it over your Legos and it'll detect which step you're on and what Legos you should be looking for and outline them in the video.
That's a good application. So basically, all the Legos models are trained beforehand, and you just select which ones you want to find, and you have a pile of Legos. Now all you need is a robot which can go and then just separate them out also, right?
Right.
Okay. All right, guys. Any other questions here? We still have some time here. Students, go ahead and ask questions. You go ahead, Matthew. Yeah.
Yeah, so the I noticed there's a lot of matches, like even they're just not as concentrated, right? Like when you're over on the right hand side of the screen. Is there some kind of a like thresholding that you thought of applying to say, yes, this is a match, and no, this isn't a match? Other than the visual, like.
Yeah. So that was definitely something I considered adding because the visual was a little messy, like you said, with all the matches going around. This was unfortunately, it was a byproduct of us trying so hard to do the machine learning that we started having limited time by the time we started cracking the ORB detection. And we pulled it together with that, but then anything else I tried to add into it started messing up our code, and we had to, in the end, go with this.
Yeah, right. Yeah, that's why I asked, is because I know when we've worked with Orb in our project, I think it was a project, I had a hard time with determining a match. So
yeah.
Yep. So again, when you are doing orb matching, it's about the key point and the quality of key points you're detecting. And again, you have to go with a confidence rating, like how many good matches. So you have to create thresholds, very dependent on your image, your lighting, your object. So it's a tricky thing to tweak, which is why, you know, sometimes you feel like machine learning stuff, if you can train it properly, takes into account all variations in the image which you might encounter in reality, and then help you solve the problem. All right. Any last questions before we move on? And if not, you guys did a great job.
Thank you.
All right, we're moving on, and now we're going to group number 3, and we have a Connect 4 game win detector. So take it away.
Yep. Do you guys see my screen?
Right. So to make sure to start with your demo video first.
Yes. Yeah. Okay. Do you guys see the video?
We can.
Okay. So, so my name is Baehr. My partner is Antonio. Montagna. I guess I can't pronounce names today. Antonio. And our project was creating a Connect 4 wind detection, and we included AI in there, even though it's not necessarily a intelligent, like any form of intelligence. It's more of a just algorithm, but you can play it just like a normal player. So it does seem like a like an AI. So I'll go ahead and play the video for you and show it off for you guys. So right now right now what I'm doing is I'm playing the game from the start and showing off that the AI of the code can predict like the best case best moves for each color. Right now I'm in that first bit, it did red and yellow, but right now I am starting to actively play against it. So I'm placing all the yellow chips for the AI, and I'm playing as red player. And so now the AI wants to block me because it knows I can win there. Place my the next red chip down to continue the game. Then place another red chip, and then now the AI has found a winning solution for itself. And then another clock cycle, and the game determines the winner. And these next few clips, I'll be showing off the different win conditions. So this will be the horizontal win condition. This next one is right diagonal. And left diagonal. Oh, I must have had two horizontals in here. I wanted a vertical clip in here. But we saw a vertical wind detection at the start. And to accomplish this game, these are the different types of filters we used. And yeah, that was our project that we did. Let me go back to the presentation. Do you guys still see my screen?
So as you saw, we are doing a Connect 4 game and it's giving next move suggestions and wind detection. And I'm Antonio and that was Jacob speaking earlier. So to introduce our project, again, at risk of sounding repetitive from the video, we are determining the optimal best next move. We are detecting and displaying the wind conditions. And we are using an AI player, so to speak, to build the confidence of the player to take on any opponent. So I know from my experience, I'm the youngest kid in my family and I could never beat my siblings at games. So now any younger siblings that share similar experience as me can go take on any smarter opponent and beat them with confidence. So for our project environment, we initially viewed this as being able to just sneakily set up a camera in front of your game board and be able to play it with maybe no one really knowing what was going on, just you having a computer next to you and a video camera. But we found that lighting was very important, as Professor Mirza made very clear throughout the semester to us. And so because of that, we used bright field lighting and we created a small housing to go around the Connect 4 game. Initially, we used black backdrop, but we found that a white backdrop provided a cleaner image for processing. Can you go back one slide, please? And so for image processing, the filters that we were using to view our game board and detect the game pieces, we started with a bilateral filter, which would then allow us to better detect the edges using Canny. And you can see in the middle photo that we were able to determine the edges very well with a white backdrop. It gave us very clear circles around each game slot on the board. And then with that, we were able to do contour detection, and it's a little difficult to see in that image, but you can tell that most of the game piece sections on there are highlighted with a green circle around them. You can see that bottom left one the best, but now I'll let Jacob explain our game processing.
Yeah. So once we did identify the contours, we were able to create a digital representation of the game because since the program is essentially, it essentially doesn't know what it's looking for. And so we had to basically like give it the tools necessary to understand what it's seeing. And so the way we did this was we represented well through the filters and through, I think I have on the actually in the next slide, you'll see by understanding the two separate players and their colors, we were able to draw up a digital representation of the game. And we did this in a matrix format because you'll see later on that it was it's very easy to be able to, it's very easy to manipulate and process like different types of winning algorithms and conditions. And so in this slide, you can see once we did find each of the colors we were looking for, we were able to create different masks for them. To the left, you can see the red mask. And you can see that for each position that the red player is in, it will fill in a slot in the mask. There is another mask for or another grid for the yellow. Just did not display it here. And so once we did have each separate matrix, we were able to run those vertical, diagonal, and horizontal conditions just by using some basic like Boolean operations to make it to briefly run through it. Vertical conditions, we were able to use a simple loop to check for what we would do is we would take the 4 rows, for instance, the bottom 4, and we would use a Boolean AND operation, or not Boolean, a bitwise AND operation. And if there was any, if the final result was in fact 1 in that column, then it would obviously the output would be a 1, and so we would determine that there is a vertical win condition. For the diagonal, it's very similar to vertical. The only difference was we had to in the matrix or in the grids, we would have to actually rotate or shift the bits to all align with each other, and then again we would AND them all together to find whether or not the column was filled with a vertical win. And then the horizontal was very simple. What we did was we scanned all the rows with what we did was we checked each row for specific values in decimal value. The only winning conditions in a row would either be like 15, 30, 60, 120, and yeah, I believe 120 was the highest you can go. And so by checking those decimal values, since we had essentially not a decimal number, a binary number for each row, we could then check for the horizontal win condition. And the summary of our project was pretty successful. Thanks to the works cited that we'll get to in a moment. We did find some neat online resources that had a AI algorithm that helped us a lot with determining the best move. The win detection was definitely challenging, especially figuring out how we can manipulate the grids. And by applying a lot of the things that we learned about lighting and as well as filter and edge detection, well, by learning that in class, it allowed us to succeed with this project. And this is the works cited that we had. And yeah, that's it.
With that, are there any questions?
Well, good job, group number 3. Good demo, good presentation.
I have a question.
Yeah.
And I'm coming to this from no knowledge whatsoever about what you learned in your class. But I noticed when you did the diagonal win situation, there were 2 options to win.
Oh, yes.
And I wondered, how did the machine choose the option that it chose?
Yeah, so I will actually go ahead and present this screen because it's a little easier to see the grid itself. So yeah, so you are correct that there are 2 different diagonals that we had to work with. The first one was the right diagonal, and that one, the way it worked was it would pick. So the each condition is only 4 coin or 4 chips, including the diagonal. And so what we would do is we had a loop run what it would do is it would choose 1 row. It would do nothing to it. It would just take it as it is. It would then increment to the next row. And what it'll do to the next row is shift it over to the left 1. And then it'll proceed to the following, the row after that, and shift that row over twice. And then the final row will be shifted over 3 times. So if there was, I don't know if you can see my cursor, if there was any diagonal, it would essentially shift all the bits right vertically on top of each other. And then with that output, we can run an operation on it to determine if there are 4 rows stacked or 4 bits essentially stacked on top of each other. And then the same thing can be done for the left diagonal. However, instead of starting from the bottom, we started from the top, and we would well, I guess we would still start from the bottom actually, but we would just shift that bit over 4 times, and then go to the following row, shift that bit over 3 times, go to the next row, shift it over 2 times, and then the final row, we won't shift at all. So it would still align all the bits all on top of each other.
So there was a good technical explanation, but I noticed the same thing, Deborah, that, you know, when you have multiple choices, highlighting one, you will win.
Right.
Pick at least one. That's how I use my navigation. If it shows me a way, it'll get me to the destination. Maybe not the very best, but it will get me there. Okay. So any questions from others? I do want to rename this project as Younger Sibling Unite, right?
Yeah.
It's designed for them. So while others are thinking about their questions, how did you select the filters for this project? You know, what was your thought process behind it when you selected the filters which you used in the project?
Well, it kind of just came back to what we learned in class, and there's a few different methods we're initially trying to go with, but we found that just detecting the actual contours of the circles was the easiest. And with that resource that we found online, someone actually had a brilliant way of drawing up essentially like a grid from contours. So exactly like that, like drawing almost like mapping positions from contours, kind of similar. I don't know if you'd call it it's not really object detection, but instead it's really just just finding all the contours and then giving each of them a position within a grid.
We use the concepts taught in the class to first bilaterally filter it to then gain better edge detection. And then using that edge detection, we could select the specific areas we wanted to search for colors so that when we would implement our color masking filter, it would look only in the specific places needed and wouldn't get as thrown off.
Good. So it worked. So that's great. You know, you selected the right filters there to make it work. Now your setup was very structured, right? You had the game board and the camera. What would happen if you moved the camera?
Yeah, so the game, if we were to move the camera or even move the game board itself, it will still detect the contours, and it will actually adjust the or at least like what you see on the screen when we draw all the circles. It will adjust and we'll be able to detect all the edges of the contour. However, there were some instances where that it would actually almost squish it, and it would think that basically what it would do is it would think that the game is smaller than it actually is, in the sense that it would think there's maybe 6 rows or 6 columns instead of 7. And we tried originally we were trying to go with more of a like a live video. So what we did in the project was instead of having it constantly process, we just had it on a process on a button click, because that helped a lot with getting accurate results. We found that when we were trying to do live processing, there's a lot of technical issues and a lot of crashing involved with Python. And so I think if we were to want to do any improvements in this project, it would be to really make it robust with the camera angles.
Right. So all those are part of the learning process to make things happen and make things work.
Yeah, and Jacob, if you could go ahead 2 slides, just to answer that a little more in layman's terms. You can see that on slide 6, you can see that yellow was being detected much better than red. And so imagine if we weren't in a controlled light situation, the red was even harder to detect. So with a little more time, I think we would have liked to create a better red mask that would identify it better in more lighting conditions. But given the time we had, to eliminate the most headaches, we just went ahead and created a box and did what we were taught in our labs to create a controlled environment with bright field lighting, and that just helped us proceed with the project for the time being. Although our initial vision of the project would be to work anywhere.
Yes, so you guys did color detection, so lighting is crucial for good color detection. Actually, you're differentiating two different colors, so it makes the problem a little bit easier than can you distinguish between two different colors and then go with that. So, but again, lighting is very important. Can you go back to slide 4?
Yeah.
I want to point out something. You see the distortion in the camera, right? And
Yes.
all that radial distortion going on.
Right.
So in industry, if you're using machine vision applications, that's why we did in our lab also that the first thing we do is a GPM, global pattern matching. If you had trained, let's say your system to recognize the Connect 4 game board, empty game board, that way it will find that in the image and then it can straighten it out. And then you can just use region of interest to see is there a color there or not, or if there's a color, which color, which could make this more robust. But again, these are all the steps you take after doing what you've done initially, and then make it really robust, that you can have the camera at a different angle, it finds the board, and then it places region of interest on where there should be pieces, and then it just looks in it to check the color. So those are some of the ways you do industrial applications, and kudos to you that you did a great job and it worked really well. And you wrote an algorithm behind it also to have fun with the game itself.
Yeah, thank you.
Any last questions for this group? If not, you guys did a great job again. Okay, moving on. We are going to group number 4, and they did an automatic face blurring tool. Take it away, Hasin. You're muted, Hasin.
Yeah, I'm sorry, can you hear me? Is it the screen?
Yes, we
Okay.
can hear you and see the screen.
Okay, perfect. All right, so hi everyone. We're group 4. We did an automated face blurring tool. My name is Hasin Chowdhury. My partners are Pankil, Dave, and Lucas Moticsak. So I'm gonna play the demo video right now to explain how this works.
Okay, so for our project, we did a automatic face blurrer that uses facial recognition to selectively blur or not blur people's faces. So when we start the program, when we start running it, it gives you two options, being webcam mode and video mode. So first thing we'll do is run webcam mode. Do we want to save the output? No. So because it's webcam mode, it is tied to the webcam. It creates another window which will show my face when it's there. It will show my face. Now, from here, there are a couple sliders which I can use to adjust how this goes. There are subjects. I can choose to blur subjects. Subjects are pictures given to the program that it will use facial recognition to know if it's looking at those faces or not. There's a tolerance that it allows to look at them. So if I were to turn the subjects on, because my face is in that folder, I turn it up, my face will be blurred. If there was somebody else in this video, their face would also be blurred if they were not in that folder. All right. From there, I exit out of the code and I can run again. And those are the main things within the webcam mode. From here, I can run video mode. So, do I want to save the output? Why not? So we save the output. Now, it says performance mode and video output. Performance mode is running it on the video without all the sliders. And there is a reason why I'll show you at the end. But right now, we're going to run it with performance mode. What do I want the Gaussian filter to be? 90, all the way up. What do I want the facial tolerance to be? Now this is the end result of all the math done to say whether or not a face looks, the face that is going to look at looks like the image given to it. So let's set the tolerance at about 50. Do I want to blur the subjects? Yeah, why not? Do I want to blur the unrecognized faces? No. So then it runs, and this actually takes a while to load. We have a 13-second video that is already in there that we are editing. Okay, so now it finished processing all 260 frames, and from there we have a folder called video export, which exports the video to, called final, and it just automatically calls final project video. Here you can see my face being blurred and the faces of my partners being left normal. All right, and so from there, I want to show you why we have a performance mode. Because now let's run it again real quick. Let's run it video mode, okay, 2, and then let's save it again. But let's not run performance mode. This makes a new window, and it will have all of the sliders. And give it a second. And as you can see, it runs pretty badly. While I can change things in real time, like blurring my face like that, changing the blur, not blurring other people's faces, it runs quite slow. And so it's easier just to set defaults rather than having to run this and figure it out from there. All right, and that's about it. Thank you.
Okay, so if you can hear me, so that was our demo video. Here as the introduction, so face blurring, we decided to do this face blur automation tool is because of the in today's world, privacy is a very big thing. If we are doing we see a lot of blogs and a lot of and it's been a trend. It's been going on in the internet world, and it's been taken over by a lot of people. Consent, like professional calling, government security, you can use this in everywhere and anywhere. The face blurring tool, I think it is going to be very vital and important when it comes to securities. Like any sort of government official like videos, if they want to blur out certain faces, if they don't want to show certain people for certain reasons, this can be very, very vital. I think what this tool gave us to what we implemented from the class as well. We can apply filters on faces, and now we can actually detect the face to blur it out. We can, like Lucas showed in the demo video, we can actually edit other people, and we can also teach it to like a certain person, only a certain person would blur out. So let's say a person's like in a video and we don't want to show him like a secret meeting or something, and we just blur his face out. I'm just talking out of like a movie or something. Obviously in real world, it would not happen. They would not release a video of president. They don't want to release it, but I'm just saying for any other purposes, internal government purposes, professional calling, obviously. So let's say we're on a Zoom call and we just want everybody behind us to be blurred out, and it can be done on live. Like in the demo video we've showed, we were walking live in and it was blurring out faces. And then consent obviously is nowadays everybody, a lot of people don't want to be in other people's videos because there's a lot of pranks, a lot of blogs and a lot of stuff going on the internet. So so when somebody doesn't consent it, or somebody like out of the goodwill, they want to blur out other people other their subject in the frame of their video, they can use this tool and they can blur out all the people, and like when they select other in the slide bar, and they can blur out all the faces. Moving on next, I'm gonna hand it over to Luke. to talk a little bit about the process.
Yeah, so the way that this works is that the actual code itself, the facial recognition code part of this, it creates certain landmarks on your face, primarily focusing on the eyebrows and the chin. And what we ended up doing was taking all those landmarks, putting them into an array, and then blurring those landmarks in the array itself, and then returning them as a mask that which will then be reapplied to the image that is being presented. And one thing I didn't go over in the demo video is that there is even a refresh frame rate that we had set to 3. So every 3 frames, that blur would be refreshed. Am I echoing on your part? Okay. So if you go to the next slide, you can kind of get an idea. So this is a picture of Obama, which works similar. Where if you can see on the on Obama's face, many of the landmarks are focused on the eyes, eyebrows. Oh, that one's the mouth, but ours more the chin. And we took those and it returned like the image that you see, the second part where it has the mask on top of it. All right, next. Thank you.
So on this project, we come up with the 2 different type of application. So on application number 1, we feed in the person's face and that only particular face get blurred out. And for the second application, we feed a face to the application, and then that person's face doesn't get blurred out, and everybody else gonna get blurred out on the video footage or live stream. So on the next screen, we're gonna have a demo video showing one of our. Can you play the video, please? Yep, as you can see on this video, that one of our group member on the center, he is being blurred out, and rest of us is not blurring out on the video. This could be used on the different various products. It could be used for the government purposes. It could be used for any kind of television streams, anything online. It could be used to blur out your ex from your family picture. It has the multiple reasons to use it. On the next video, we have application number 2, where we have one of our group member named Hasin. Nope, that's the same video. Go to the next one. Yep, that's one. Yep, as you see on the video, we have one of our group member, Hasin Chowdhury. He's not been blurred out because we fed his picture to the software, and rest of us is blurred out on the video. As we talked about earlier, this could be used for Zoom meetings, live streams. It could be used for the vlogging. It could be used for professional and educational purposes as well. So this could come out very handy and upcoming virtual world. On the next slide, we're gonna have our another group member, Hasin, gonna explain about the improvisation on the program. Yeah, mute again.
I think, yeah, I'm sorry. I think there's a lot of improvisation improvement can be done to this system. So we did blur out, so we're in a very initial stage where we blur out people's faces, but I think it can be more robust. The program was like all of a sudden it would just blur out a certain person that it shouldn't blur out. I think it's because of the facial structure. So what we can do is we can also, and I've seen certain examples where they use like a SVN classifier to store more data and more specific data to your facial structures, where you can use it as a repository to feed it to the program, and the program will just take that information, and then they will specifically blur out that the face. I also think for like our demo and stuff, we didn't have like a good hardware. I think a better webcam, like a better camera system would be really helpful in that. It needs to have like so when you turn right or left, that's where it loses sometime you're blurring your face. So what it could be done was we can divide the face into 2, teach it as like 2 different masks, and put that information in that SVN repository, and then we could just use that information. So whenever you're turning left or right, you're still seeing the person's face. I mean, it's still blurring it out, not seeing, I'm sorry, still blurring it out, still getting detected by the program, and still blurring the face out. That could be done. So more robust in detection, more stabilized, multiple faces to blur.
To butt in really quick, one of the issues that we ran into is that we were only using one picture in portrait, which if we did the thing with the SVN, we'd be able to store more images. That would give us more data to work with, making it more effective, rather than having just one image, which is a very specific position that the person has to be in.
Yep. So moving to the conclusion, I think this is a very, very good tool for everyday usage. This can be done and more to come in future, because I've seen a lot of YouTube videos, and there gets a lot of problems where people don't want to be in somebody's videos, and vlogging is a big thing now. Like everybody travels, vlogs, everybody wants to show like the world, okay, well, we're doing some scenic videos and stuff. And when you're taking drone shots, there's a law, like you cannot fly a drone and somebody is in your video, and if they get into your video and they actually want to sue you, they can. I think this thing can be very, very important in saving those errors. And then more improvements, I think, can be done, like I've talked about in a previous slide, for improvements and better quality equipments. I think more higher definition cameras, obviously like 4K cameras and stuff, will get us more reading of the faces, more specific pixels that we can use. Here's only 256 pixels were used, and can use thousands of pixels, and like use like SVN repository. It's kind of a little expensive to buy online, but if we can get those working, I think we can make a great tool in future to like actually market it and actually implement it in everyday life. All right, thank you, everyone.
Thank you.
Any
Thank
questions?
you, Group 4. Good job. All right, let's open up for questions. We have a couple of minutes here. Any questions?
And by the way, sorry for the inconvenience that our title is blocked out for some reason. I just noticed it on the screen.
Oh,
I noticed it a little while ago. Didn't want to bring it up though. It's
sorry for that. What is there though?
I'm not sure how to like take this. This is okay. There we go.
well, you can.
There we go.
You aren't missing too much there. It's
I have a question.
Yeah, go ahead.
For your GUI, what did you use to create your GUI?
We didn't really use a GUI, I don't think.
Well, the sliders, like.
Oh, my bad. A GUI. We on one of the previous projects, one of the things was just implementing sliders. This actually came out of the debugging process. While we were doing the webcam, it was annoying to go back and constantly retype in certain parameters we want to change or anything like that. So I just took some of the like code that we used on the previous project, implemented it, and turned out to work. So that made everything a lot easier as far as debugging.
Okay.
Okay. Is it just out of curiosity? Is it like the same Python library that was mentioned earlier? I forgot what it's called though. For Nishchay's project. Do you know what? Oh, okay.
No, that was the first time I've heard of those libraries actually.
Okay.
Yeah.
Yeah, I mean, this is a great security app, very timely, shows of what's going on, and many uses here. It'll be really good if you can blur faces in reality also. Somebody's face.
Yeah, if everybody's got Google glasses on, maybe.
throw a blur in real life.
Pure anonymity, you know. Yeah.
Okay, so I do have a question. So you mentioned that you had issues when you were trying to run in not performance mode, where you can tweak stuff. Now, were you really processing each frame of the video?
Yeah.
Okay, so do you think there is another way to do it, just using some keyframes or skip every so many frames and
So
keep
I
the
think I
blur.
misspoke there. I don't think we weren't processing each frame. Oh, actually, we were. It was just refreshing every 3. A way to actually make it easier was to change the refresh rate that we noticed. The problem is if your camera is running 24 frames a second, you do 10 frames, that's almost half a second. And I'd move like this, all of a sudden the blur is still here for half a second. You see my face. So it was a mix between, that was one of the ways we found of making it work a little better. I'm sure that if I had more time, which is always it's always that case. If you have more time, I could find a way to make it. We could find a way to make it work better from there. But the way we had it was a balance between performance and actual effectiveness. So we decided it was a better idea just to do the defaults rather than, for the presentation at least, rather than trying to, make it seem like the thing wasn't running at, half a frame a second.
Yes, so yeah, you're right. I mean, fast motion, then you have to process it very quickly. So what kind of computing power did you need for the app to run it well?
So we'll peek behind the curtain. We ran it off a fairly old laptop. So I don't actually know, considering the one we were running it off of. But like even on that one, it ran decently enough. I'm sure that if we had better hardware, a better webcam for one, because you'll notice that in one of the videos, Pankil is like half a foot behind me and it doesn't pick him up. Then he moves a little bit forward and it does. If we had better hardware, better webcams, better computers, better processing power for one, I'm sure that we could make it run a lot better. But just to acknowledge, yeah, we were running it on a pretty old and not as up-to-date laptop.
So you're right. I mean, it does make a difference. Since you're running machine learning algorithms for facial detection and recognition, some of the platforms, with GPU-based platforms, are really adapted for this kind of use and very efficient. We talked about one of the NVIDIA Jetson platform. It's like $100 platform which can run several ML algorithms in parallel and very efficiently on videos also. So that's another thing, class, is to select, when you are actually doing it in reality. I mean, you guys are doing it to experiment, which is great, and you made it work, learning a whole lot along the way. But if you're implementing this stuff in reality, you have to choose the right hardware also to run it on. And it doesn't have to be super complex, super high performance hardware, just the right type of hardware for that particular algorithms you're running. And then you will have very good results. All right, any last questions for group number 4? If not, then great job, group.
Thank you. Thank you.
And we are going to move on to group number 5, which is OpenCV augmented reality object manipulation. Take it away.
Okay, so let me just really quickly make this full screen. Okay, so everyone can hear me? So my name is Matt. My partner is Mohammed, and we're group number 5. So our project title is 3D object manipulation. So augmented reality is a big part of today's world. I'm sure we've all used Snapchat filters that use augmented reality. But the goal is to project a realistic object into the user's field of view and ideally allow some interaction, kind of blending the real world with the virtual. So obviously in this kind of application, any kind of hand manipulation is very important for an immersive experience. We're used to using our hands for things as humans. And so this picture here is, I would say it's probably a medical student or something being able to view the human heart for educational purposes. Applications for a product like this, a hand track or a hand manipulation augmented reality product would be gaming. So this project started out as we had 2 goals. We had our ambitious goal and our more realistic goal. So our ambitious goal was to try to do 3D chess in augmented reality. Our backup was to be able to manipulate one object in augmented reality. So gaming is a application. You could do chess. You could do any number of games. Education, as we saw in the previous picture, could be a application, and the industry could be as well. Having a meeting and being able to hold a part in your hand and manipulate it with your hand would be great. So I'm going to pass it over to Mohammed to talk about pose estimation and calibration.
Yeah, so hi everyone. So to accomplish the manipulation of virtual object, we first needed to calibrate the camera, as in many other computer vision programs. As you can see in the pictures on the right, we used a checkerboard to calibrate the camera and use the intrinsic matrix to be later used with the homography from the Oracle code to find the transformation matrix that will be later applied to the object. To calibrate the camera, we used OpenCV, a function called find chessboard corners. And with the camera calibrated, we can go on to detecting hands using a library called MediaPipe, which is a machine learning vision library by Google. Matt will explain our process in the following slides, as you can see here. You're muted, Matt.
Thank you. Thank you, Mohammed. So yeah, we use MediaPipe for hand tracking, and MediaPipe was a very easy to use, very cool hand tracking software. I believe they also do faces and some other applications, but you can see the key points on the hand there, and that's kind of what this library gives you. So we were able to copy their code, their base code that just gives you the key points, and then we could add to that and manipulate and utilize those points, those coordinate points of the fingers. So we had to come up with some hand gestures. A little bit of a formatting issue there, I apologize. But so when you're not doing a gesture, you just have your hand out there, you have a cursor around your thumb that's blue. When you're doing the grab gesture, that's pinching your index finger to your thumb, and the cycle between different operations is the middle finger to your thumb. So, and the way that we did that was a very simple distance calculation between the points given, the key points given from MediaPipe. If you reach a certain pixel threshold between the 2 fingers, then you know that you're doing that gesture. We had 5 different operation types that you saw in the video. So we had translation, just moving the object, about the screen. We had 3 types of rotation about each of the axes. And then we had scaling. Each of those posed their own individual challenges in bringing pixel displacements into the matrices in an effective way, which Mohammed's going to touch on.
Yes, so like Matt said, now that we have the detection of the hand, we can track the fingertips. We're in this program, we're using the thumb. So we can track the thumb fingertip and calculate the displacement of the thumb. Right here, you see the rotation, general rotation matrices, which we'll be using to apply 20 degrees angle rotation to be multiplied by the current transformation matrix of the object to obtain the newly transformed object. And the next slide, if you go into the next slide, you'll see here the full system flowchart. When the program first starts, we start by scanning for the Oroco tag. If the tag is detected, we calculate the homography from the Oroco tag by using the camera parameters and also the homography matrix from the Oroco card. And by that, from that, we obtain the transformation matrix we apply to the object. And after that, we enable the manipulation. And if a hand is detected, we decide which gesture is shown on the video, whether it's pinching or cycling for the different transformation modes. Onto the next slide. So as Matt said in the beginning, this technology is still emerging and isn't anywhere near its full potential. There are a lot of companies developing glasses for this and head-mounted displays for this specifically. Some future improvements I could see with this, just utilizing a better, maybe there's an open source library called OpenGL where we can use a more resolution objects or maybe even using a graphic engine. So and integrate OpenCV so we can get the full experience, the full immersive experience of augmented reality. On the next slide, you can see some references and resources we used. So we built this hand manipulation thing on an already developed object where you can see the flags with the Oroco code, and then we developed the hand manipulation onto it. Any questions?
Yeah, I actually have two. Did you guys actually hook up to a Oculus Rift or an actual virtual reality headset, or did you mainly just use a video? Okay.
We only use the webcam.
Okay, yeah, because I was gonna ask how that went, like if that was hard or not, because I'm just a curiosity of mine. The other one, you said that the way you judge whether going from transition movement was the distance between the fingers and the thumb, a pixel. Would that be affected by, let's say, a person had like bigger or smaller hands, or would calibration take care of that? You know?
It does. I've tested it with my nephews who have much smaller hands, and so it also, the distance that you are away from the camera matters as well. So in code there is a parameter just called R for radius that we made, and that's the radius of that circle, and that can be adjusted. You know, if this were to be a product, it would be in some kind of GUI.
Yeah, or like a calibration thing to take. Yeah, that makes sense.
Yeah.
Okay, thank you.
Yeah. Before I ask my question, well, good job, guys. Great presentation and great video.
Thank you.
Okay, so my first question is, what is a cow leopard?
I don't know. So that I guess I can go back to it. So what we tried to do here is we found this object here is the one that was in this gentleman's code that allowed the projection or the pose estimation and calibration. We wanted to show off that we could insert another object in there. So we found a cheetah, I believe it is. Kind of looks like a leopard. but then you have to give it a texture. And we tried to give it like a leopard print, black and white leopard print image from images, but it just ended up looking like a cow skin. So called it a cow.
It looks
cow
like the
leopard.
QR code is on the animal itself.
Kind of, yeah. It's not that's actually just leopard print, but I think it just grabbed a small region of the image we gave it, and so it looks pixelated.
And the second very important question, were any animals harmed when you rotated them through all those moves?
Only virtual animals.
So actually going back to this point, I tried using OpenGL to basically spawn better looking objects, because right now we're basing the object spawning on a file OpenCV provides. And so we didn't really find a texture that works on the leopard, so we just went with this. But if we had time to use the OpenGL, I'm sure that we can get better looking objects.
Well, I have to say that you took on a pretty big challenge here. AR is not that trivial, especially if you're doing 3D objects, visualization and manipulation. So yeah, I mean, what you accomplished in the short time is commendable. It was very good.
Thank you.
One of the things I want to mention is that you took the excuse me, right approach for building using pieces like media pipe, pre-made code, smaller pieces, put it together, build an application on it, which works well. So this is a good approach. You don't have to do everything from scratch. You don't have to create a machine learning program to teach your hand motions. If something is already made, train it, adapt it, utilize it, and move on with what you really want to do. So I would recommend all of you, when you're building app, look out for pre-made libraries, pre-made apps to stack together to build on, which is a good way to do it. Any questions from the group? Okay, well, so I'll ask another question then. When you did those translations and rotations, did you try it on the AR image itself when it was on the target?
I'm not sure. So I think I understand the question. Let me take a shot. So you'll note, actually you notice when we're doing the rotations, it is doing the rotation about the axis that is associated with the object, not the world axis, I suppose. So when I was doing translation, going left and right was fine, and it depends on the way that you spawn the object, the orientation it is spawned in. But you would notice it goes left and right, okay, but then when it going up and down, it kind of goes into the background a bit and comes back. So that's just because there's an axis or a coordinate system associated with the object, and that's what's actually we believe being transformed. So
what you did was very good, that you connected the hand motions to operations on the object. The next step would be to take it in the actual real world coordinate system. So then when you translate, because you have a QR target, which can give you a frame of reference in the real world, at least for a flat plane. And then you can move that object in that frame itself. It will look like it's moving in the real world. And if you take it to even next level, because I'm telling you, AR is not that trivial, but again, you can build it up like that. If you have a 3D map of your world, then you can conform to the physics of the real world. So it reaches the edge and falls off. You could do all that stuff, and it just means that you need more sensory information from the real world and mix it with the reality you're creating and let it behave following the physics of the real world. But now you can see when you start doing all that thing, you blur the line between what's augmented reality and what's the real world. And that's the whole idea of augmented reality, that you feel like that object exists in your world. And as one of the questions that did you use a headset? If you start using that, then it's seamless. You can look at it on your tablet, on your smartphone, which is a great way to view augmented reality. But when you are wearing headsets, then the blurring of the line between reality and what's virtual is, you can make it so good that you cannot differentiate. So that's excellent that you guys tried this out. Any last questions for this group? All right, with that, you guys did a great job.
Thank you.
And
Thank you.
I want, we have some guests. If you have any last things about what you thought about the presentations and any tips for the students, I would open the floor to give them some comments.
Yeah, Khalid, if I may, Paul from FANUC here. Congratulations, everyone. I think the presentations were very well done, very concisely presented with confidence of the material. So obviously you've done a lot of homework to get to this very short challenge that your instructor put toward you. And I know Mr. Misra often said and challenged you to think about the future and how this technology that you're testing in the lab is going to be used in industry or in the consumer world. So often the lab environments are very well controlled with very limited variation, which is not what you're going to see in the real world. And we get it at our company as well. We have many labs, people working on research and development operations, and we try and instill some real world variation into those tests to try and flesh out those things before they get out onto in the field. So appreciate your work. Looking forward to Thursday as well.
Thank you, Paul. Any other comments from our guests?
I would say that among this crowd today, I'm certain I learned the most because I knew the least coming into this. So thank you all. It was very informative sessions. I learned an awful lot about vision systems, machine learning, some skills I didn't think I would ever need to possess, but I certainly have now. So that's wonderful. And you all have wonderful careers ahead of you, and your learning curve is much steeper than it was when I was your age. So congratulations.
Well, thank you very much, Dan, and we'll send you the tuition bill afterwards. Any other comments from our guests? I know Clemens having issues with the network. If not, then there are 5 more exciting presentations on Thursday morning. Please be sure to join and support the students, and I'm sure that set of groups will do a wonderful job like this set did. With that, I would say thank you to everyone for joining today, and I look forward to in 2 days. Thank you. Take care, everyone.
Thank you. Have a good day.
Thank you. Have a good day.
Thank you.